You're welcome to another edition of our class. But today we'll be looking at the classic edition. And today, what are we going to be talking about? I think we had the opportunity to. I had the opportunity to have conversations with. There's actually a group where we have installers, a couple of them there, and before you are inducted into that group, it's a WhatsApp group. You must be those who have actually purchased our manual. After you've actually spent money buying manual and you still have some challenges, and I feel I cannot take my time to even pass that same information. So after that section, I dropped the question like, if you know any area you're having challenges, please with electric fence, drop so we'll talk about it. And a couple of them said something, and that's why I said this is the classic edition. We'll be talking about it. For one said, I have issues with gate contact. Really appreciate your concern. Okay, thanks for always being here for us. And another one still said, thanks so much, good master. Gate contact is the problem remaining for me. Okay, and I think I had 3 persons who talked about gate contact, and I feel it's important we talk about this. And another one said, I think he was talking about automated gate. The only challenge I have having a class on automated gate is for now, I'll say if it will get to a time actually, if it's going to be like a demo, a table kind of, where we can see that, but most times we go to a site, you just want to deliver. But for now, I think we're talking about the gate contact. Okay, before we go further, I want us to, let's check this drawing. I took my time to illustrate what the gate contact actually look like. Okay, let us take a look at this sketch. Now, this is how a typical gate contact looks like. I tried as much as possible to go into it to see what we have there so that it will be easier for you when trying to connect a gate contact. Oh man, that's an error. Wow. This is not an X. This is no X. Sorry, that's an error. Gate contact uses just live. Okay. In, return. Sorry. Live, return, live in. Sorry. The first, that's a mistake because there are gate contact that has 3 terminals. This is just 2. So for the 2 terminal kinds of gate contact, you don't use the earth at all. So it's just your live going in and returning from the other side. But if it's a 3 terminal where you have the third one, then you have 1 earth, 2 live, which is live in and live return on the third one. Then the middle is earth. So, but this one we have just only 2 terminal to contact, which is the live in and the live return. This is how the typical gate contact look like. Let's explain what we have here. Now for gate contact, this part, this is the female. Now there is actually a spring pushing this in this direction. It will push this. This is this is a terminal. This one, there's a terminal from here to this very, a plate. You see that plate at the front of those things. This terminal is actually connected to this plate. So, but there's a spring always pushing both to come meet this other one here. Now, note that this one that you have at the front here, there's a link between the upper circle and the lower circle. Anytime you push this gate contact, when the male comes in contact with this, it opens up from this contact, so there's no more contact between here and here. This is a typical gate contact, what it looks like. So I want you to understand something first, so that when you're trying to connect to a fence, you know what you're dealing with. Before we talk about the fence, now let's explain the gate contact and how it works. So this has the terminal here, and this is where at the back of it, where you have your plate, where you have your screw to hold it, the terminal screw to hold this part. Then here you also have that terminal screw to hold this. But I want you to understand what we have inside. There's a spring. That's why when you push a gate contact, you're forcing a spring actually in. Then by the time you release, the spring returns. And this one comes in contact with this. This one comes in contact with this. Because there's a link here, it closes the fence. So if this part, let's link this part to a fence. Let's assume we have a fence here. We're going to have another gate there. This is the fence. Let's say we have we can have this on the fence or this side on the fence. Either of them can be, okay, this side on the, should I say on the fence here. Wow, my marker is faint. Somebody talked about my marker yesterday. Sorry, I'll try get another one. But if you can also get for me, I'll appreciate. You can just get loads of it. Let me have them enough. All right. Okay. Let's assume these are fence. Say this one is here. Let's say live F, live, live, F, live. Then we have this to this live, this one to this line, and this to this. Then this goes all the way to this. Now, if you notice something, if this, by the time this comes in contact with this, because default, the spring will always push it out to touch this guy here. So it means there is supply. The contact is close here. So you have a closed circuit. By the time someone pushes, gets in contact with you, have this one linking up with the one at the bottom. So it means you're having a closed circuit, right? This is a closed circuit. All right, fine. We can assume our energizer can be here, but let's leave the energizer aspect. The main thing we're talking about is your gate contact. Okay, let me assume we want to incorporate an energizer here. All I need to do is to come here and fix the energizer here. Let's assume we're saying this is in, out. This is in, fence in. So this is an energizer. This is live in, and this is live out. So this one comes to live out. Let's assume we have our earth to this fence. Note that for the two contact kind of gate contact, you don't need to draw your earth to those terminal at all. Now this is it. Our energizer feeds this guy here from here, live is live in, goes all the way, gets here. Because this is default, it's normally closed, because if the spring pushes it together, it closes it here, so it returns the flow. That's why whenever your gate contact is at rest, even if your gate is connected, the alarm doesn't go off, because here immediately this one is like a loop already closing it. But immediately you bring this guy in to push it here, let me show you the connection we have here. Why this one would not trigger an alarm. But this is to your gate. And if there's an issue with this one going to the top of your gate, then you'll be having issue feedback to your energizer, which will be a problem. Now let me show you. Let me do sample A. Let's assume this is sample A. Sorry, don't mind my marker. Let's say we have 1, 2, 3, 4, 5, 6. Now for your 6 lines on your fence, make sure all the lines are what? Live. Make sure, don't try to say you want to put, just make sure they are live. If you want to eliminate this one, don't even touch it, better. But either you make all live, skip some at the middle. Maybe you decide to skip this or skip this other one. But what I would prefer to always do is to leave all as live. So any of this line that you break, you open the circuit. Now, let's assume this is the in here. Goes from here to this one. Pardon my marker. It's just failing. Let's assume this is okay. Let's say the pole. Okay. We've looked this way. This is out. So this is going this way. This came in this way. So my fence already, my gate, this is gate. Oh goodness. This is the fence. So this is the fence and this is the gate. Now, one thing you should understand is this part is an entity on its own. All you need to do, immediately you finish looping this fence, this section, make sure one of the wire you finish. Okay, this is the loop. I've not even connected it to this one, waiting for me to come in. Now, all I need to do here is to bring the cable from here, to this, and this one to this. So by the time this is done, it means, watch this. Now, this gate, by the time the gate is open, if I slide my slide gate, let me assume this is my slide gate. This is connected to my gate. This is my gate. This is my wheel. Okay. By the time, you know, this is always attached here. This is always attached here. You have it like this, waiting to hit this other one. Let's assume it is connected, you know. Okay. By the time this gate slides in, comes in, this one is moving, this moves, it comes in contact with this one already closed. Okay. It will push this one off, open the circuit here, and that open here, this one here, the close here, would not close it, complete the circuit from this. Let's assume now, when this is out, like when you push this one in, this one is opened. So it means this guy comes in, right, pushes it, and opens this. But because he's opening it, and this one is contacted, this is contacted, this one is closing it from this side. I just hope we're getting this. I hope we're getting it. I hope we're getting this. Okay, let me come again. I just want to make sure this is clear. This guy, by the time you release this stop, this spring shoots out. Okay, let me try explain. Let me come again. Let me explain this in. I want to try make it. I want to simplify it so that by the time you understand the principle of operation of this, you shouldn't be having problem connecting it with your gate contact after now. See, like I said earlier, only when this thing pushes the foot to this place, that's when it closes this. That's why your fence would not raise an alarm when the gate comes in as an alarm, because within that few split seconds is not enough to trigger an energizer. Have you ever noticed when you carry your lines trying to breach your energizer to trigger the alarm, maybe the live and the neutral? You notice by the time you first park, if you just touch just like a second or two, it doesn't go off, and the alarm does not go off immediately. So there's a delay kind of to actually sense, is this actually a fault? So the time this one comes in to push this off here, it will then close it from this part, from this side of the fence. So this gate rose all the way. This guy is coming here. This is this guy. I've transferred in. This is the guy here, comes in, pushes this. By the time it pushes it off this close contact, it will take the position of this close here, which is linked to the gate. So if this gate is closed, for example, now this gate is closed. You slide your gate and it's closed. Now the contact from this place is now from here to this, from here. Now let's move the movement now to here. This is it. All right, and it's returning here, completing the circuit for this one when it's open. So by the time this one goes off, this contact is open, but this one comes back here to marry this one, which helps in closing your gate contact. So if this gate is closed, this gate is brought in, and this one continues here, by the time anybody tries to scale the fence to cut any of this line, it sends a signal. It opens this circuit, sending a signal to this energizer that the fence has been breached. Security has been breached, that the circuit is opened, is no longer sensing complete flow through its circuit. So automatically the alarm here on the energizer from the energizer will go off immediately. So this is how gate contact works. It's a very simple principle, just because most of us, we don't understand it yet, but this is just what it is. It is this simple. If you can understand this circuit and what the gate contact, this is gate contact, gate contact, the female, my marker is something else. Gate contact, this is gate contact, this is the female and this is the male. All right, I think this is clear enough. If there are any questions, I just hope we'll deal with that much later. But I just want to believe after now, every one of us should understand how the gate contact works. All right. Then somebody also said something. He was asking a question. Okay. And he said, how do you link a scenario where you have two energizer or two or more energizer in a plot? You want to use not a plot, so maybe a long span of land, I want to use multiple energizer. But that's the simplest of all. I think I'll be answering that by this. Let me show you what you need to do. Let's assume this is your fence. Just 6. 1, 2, 3, 4, 5, 6. Let's assume you have it all the way. This is very simple. Now you have your brackets, your intermediate poles, Let's assume this thing continues. These are poles, electric fence poles, the brackets. These are the brackets where you have your bobbin. 1, 2, 3, 4. This is 7 lines. So sorry, this is 7 lines. I think 1, 2, 3. Okay, I don't need this line. All right. Let's assume these are brackets. Okay, Mr. Wolabi, this is the answer to the question you actually asked. All right, let's see. So, assume this is a span of, let's say, this is one. Should I say? Let's assume it's 50 kilometers. And one of the energizer, what we need to stop here. Let's assume it's coming from here 50 kilo. Okay, no, let's say it started here. So by the time I check my chart from my energizer to say, okay, a result 4 with the solid wire, I think that as at then, if I remember that chart, it can go 14 kilometers of live wire. Let's assume I've calculated all the lines and I've traveled. Let's say I decided to use maybe 2 kilometers for each energizer. So one of the energizer is going to stop here. This is 2 kilometers for one. That is the calculation for this. I will need to do that. That's not for this class, because nobody has asked that for now. So let's assume this is where 2 kilometers stops. From here, we have the remaining 48 kilometers. Continues all the way infinity to that amount. This is 2 kilometers. And I want to stop my fence here. All I need to do is for you to separate this. All you need to do is not a big deal. If this wire continues all the way like that, just come here, break this line. Break this line here. All the lines here, break them, separate it. Get your spring and your hook. Now your bobbin has different segments. If you check your bobbin line, your bobbin, you see the first section, you see another one, like 3 sections. Now this one has been hooked to one of the sections. Then you see have other spare like 2. Take your hook, put it in any of the other spare section for that line of the bobbin. Hook it here. Then put your spring here. Your spring will replace this position here. Spring, you have spring here. You have spring here. You have spring here. Spring and hook. Spring and hook. Spring and hook. Spring and hook here. Spring and hook here. So you know that spring is kind of an insulator. It's going to separate this side from this side. It will separate here from here. This was it's a long span. So by the time you incorporate that spring here, your looping from this first energizer would not be done here. Let's assume I now take this one to here. For example, if my energizer is somewhere here, I take this to here, this one, I get to the end, I loop this one to this, get here, loop this to this energizer. Then here, because my spring and my hook are separated this side from this side, the line is still straight, you still see it straight. All I need to do is have my energizer somewhere here. With because when you're doing this, because it's a long span, you might be having this outdoor cubicle, this cubicle you use in securing energizer. You have your energizer outdoor box, the outdoor cubicle where you can house your energizer. You have one of those cubicles here with your power supply, if it's going to be solar or something, or even if it's AC. Then you have this one, energizer comes in, feed this one. You go to, let's say, let's assume you want to do another 2 kilometers. Get to the next 2 kilometers. You also do your close there. This one comes here, and this one comes here into the energizer. This is just what it is. I think I want to call it a day or a class. So till we meet again, I want to wish you Merry Christmas in advance, and maybe that's why I'm putting on the red. So you can send in your Christmas present. Who will accept them. Thank you so much for your time. Till we meet again in our next class. Do have a lovely week. Bye for now. Okay.